Hello and welcome to another edition of Cloud Test Tips, testing elasticity, performance, and resiliency of containerized infrastructure. Now, some of you are following these videos, you know there is a lot of them, but this one is very special to me because it's going to show some of the unique features of containerized infrastructure, but also of a test tool to handle such features where pods would come up and go down real time while the traffic is going. So let's see the topology first. So in this particular topology, we have this UI or controller in the left-hand side, and we have this Kubernetes cluster where we have two worker nodes, and we will label them as client and servers, and we'll deploy some pods. We'll have a type of agent service. Agent services are something that Kubernetes would provide us so that the servers pods can be behind them. So let's go and see this topology first. Some of you might be new to Kubernetes, so before we go into the topologies, I wanted to show you that Cyperf itself has some documentations that can get you started. You can go to the latest release of Cyperf, and if you click on the container, you would see a lot of different types of deployment options that are here. And for example, for this topology, I would use an on-prem Kubernetes. So I'm currently SSH to this master node, where we'll see some of the worker nodes as well. So we'll use this command, kubectl get node show labels. And you can see there are three nodes here. And you can see one of them node I have labeled as client and another one as a server. Now let's open the files that we'll use to create the pod. So we are using two files. The first one would be to create the client side, and the second one would be for the server. So let's open the client file first. This is a very simple file, and you can see we are downloading the latest ECR image. We can see what is the controller that we are using. This is the Cyperf UI controller IP, and you can also add some names in the tags. Like here I am saying that this is the client pod. Pretty straightforward. Let's do the same and open the server side now. The server file will be slightly more complex, but most of the top part would be still same. We see the UI value, controller UI, the tag that we have used, and then you can see I have some readiness probes. This is where the health checks will be happening so that when the pods are ready, we'll know. And we can also see the services where we see it's beyond HTTP and port 80. So this will be the Kubernetes service behind which the server pods will be created. So let's quickly create those pods. So I'm going to use the kubectl commands. Let's first create the server pod. So I'll do kubectl apply -f Cyperf agent server AP, and I will do the similar one for the client where I'll use the client file for this. So let's do that. Kubectl apply -f, and if I do now kubectl get pods, I should be seeing two pods. And we also need to see what is the service IP that has been created for this pod. So let's get service would provide me the cluster IP. So that's my IP. So I'll copy it. And now let's go to the Cyperf UI. I'm now in the Cyperf config. I went through the browse config and took one HTTP CPS test randomly for this particular test. And you can see it's a simple connections per second test. I have my networks, and if I click on this yellow icon, I can see both the pods. These were the ones that we just now created, and you can see the same tags here. I'm going to assign them via tags rather than IP, so I'll do this first for the client and then next for the server. And there is a specific reason to do that. We are going to scale these pods at the server side with more pods coming in during the test, and their IP addresses would not be known beforehand. So if I allocated them just by IP addresses, they will not participate. But if I allocate them based on the tags, because the replicas will carry the same tags, they would participate in the test traffic at the server side when they come up. One more step for this, and that's a very important step, is to paste your cluster IP, because this would do the distribution amongst the different pods. And if you had enabled health checks in those pod files, remember their target URLs and ensure that that's enabled and everything else is same. Otherwise, these pods will not get registered and you will not see any traffic and you will not know why. This is a simple test, just like I mentioned. So let's start it. I let the test run for a minute or so. My objective was not really high, just 200 connections, but we could get a steady 1.6 gigs of throughput, and that's great. And we can see rest of the statistics. The important point to note here is that we have one active client agent, so one pod in running in worker node 1 and the second pod in worker node 2 labeled as server. And if I go into traffic agents, you can see that there is two of these IP addresses. So now let's do something interesting. What we will do is we'll go back to this master node and we'll scale up the server replica. So as we do this and we do the kubectl get pods, you would see a new instance has now started running. So it's 9 seconds. So this instance is coming up. So let's wait for this instance to come up, the health check to pass, and see what effect it has on the test. So let's get back to the test. So you can see within a few seconds of scaling up the new instance, I can see that the server agent has now moved from 1 to 2. There was a small dip during that, and we captured it in our traffic profile. And if I go back to my traffic agents, and you can see this new agent has come up as server, and how nicely the entire traffic gets distributed between the two. So this shows that the entire cluster is working fine, and pods can come in during runtime, and you can see whether the distribution is taking place. So this marks how you can test elasticity. But this also can double up, where you can start testing some resiliency and chaos. And to do that, what you can do is either kill one of the pods randomly or just scale back the replicas from 2 to 1, which would forcefully terminate one of the pods. And we have to see if such kind of action happens in real life, like a server gets crashed or elastic network has scaled down, whether the device under test, whatever it would be in between, load balancer, security devices, is able to handle it or not. So let's go back to the test and see what is the effect. And there we can see very, very quickly as one of the pod goes down, its traffic goes to 0, but the first pod, which was there as a server, completely makes up for it immediately, and you can see that traffic now goes just to one pod, and very soon we will also see this number go down to 1, and that's what happened. So you see that this is the way you can test elasticity and scale and understand the impacts, whether there were traffic failures, whether the distribution was good. And you can also use the same theory of removing pods, bringing up pods for any of the other kind of testing that you want to do. Thanks a lot for listening.